This is Sarah Woodward, a student in EDT6010, and I'm going to be walking you through the web application on the Desmos.com site for cross-section semicircles. This is an application that is used in AP Calculus class. It's used in Chapter 8 and Section 8.3 when we talk about volumes. So the Desmos calculator, if you've never seen it before, it's got a couple of nice features. One is that you can use an abbreviation to type things in. So we're going to be doing the square root of 1 minus x squared. And what we're going to do right here, I want to take this down to like almost no cross sections, is I want to find, the problem would say the area between fx and gx represents the base of a semicircle. Find the volume created by these cross sections. And this ties into the sections on integrals, because an integral is basically just adding up shapes or adding up bars or areas, very, very small areas. So the reason why this is nice is, one, it's easy functionality for the students to type in the equation. They don't have to look for a special key to do the square root. You could just type in square root like that, and the square root pops up, which I think is really nice and neat for the kids. Next, we can look at the number of cross sections. So it's nice because if you can just see two, you can clearly see this is a cross section. You can see this is the diameter of the circle, and this is the height, and you can see what it looks like. And that's important for them to see, because later on when they go to calculate the radius, they really have to be able to tell that it's really from here to here divided by 2, because that's what the radius is half of that. So let's go back to that. So we're going to look at the number of cross sections. And when I show this to the students, I would bump this number of cross sections out just to show, because when you do an integral, you're actually adding up each area to kind of show what those look like right there. And if we get too big, you can kind of see that's what happens. So all right. Next, change T to see how much they shift. So you can shift them just to kind of get like a different perspective on it. And that's the closest you get to making this 3D on this program right here. Next thing you can do is you can change the upper and lower bounds. Usually the two equations that you're given will intersect, but sometimes they don't. So this is kind of neat. Right down here. So it's kind of neat because you can change your bounds. So your bound is how far left and how far right you want your volume or your shape to go. So we're going to say it goes to there, to 0, so 0 to 1. So this would be that quarter sphere. And this is just another way for the students to visualize what they're really doing and why they're using pi r squared, the area formula for this, right? And why they're using 0 to 1 or negative 1 to 1 when they're setting up their integral. And it's nice because once they get to the algebra part, the first part is visualizing it, and that will make it so much easier once they get to the algebra, because they'll know, well, why are we setting it up this way? Why are we subtracting this? Why are we doing fx minus gx for the radius? Different things like that. If you have any questions or concerns, don't hesitate to contact me.